Right here would have taken you max maybe 30 seconds. All right, because it says determine the number of triangles, so you know it's going to be one of those that side angle, right? Which means we need to find our angle first. We find our angle first. Our angle was 28.6 degrees. They use Bravo, so we're just going to use B. That means that that angle across from it is the one that's dangling. And that is going to be my 52.5. And that means the other side that we have is 40.7. So that makes this C. And A is down here if we have one. I did all of the work I need to do. I am done doing any work. Yep.
I have a question. So we know exactly which corner B would be, but how would we know which corner A or C would be?
We know where A is because we know length A is that length that we know.
But how, would it not be like the bottom one? Is there no possibility for that?
Well, it can't be the bottom one. Well, it could be the bottom one. So we could mark 40.7 down here, but that means this arm would have to come off here. Because the only fixed point we know is C then. All right, because if I would draw the triangle, let me just draw a triangle. Actually, let's not. So I know this fixed length is 40.7, right? Because that's what this says right here. It's 40.7. So as soon as I draw my triangle like this, this is that fixed line that I know it has to be. If you put that fixed line down here, that means that 52.5 has to come off of here. Because we know for a fact that this line must attach right here because this length is stuck at this length.
Okay.
This length is stuck at this length. The only thing that's not stuck is where this intersects this line. Okay? So as soon as I know this fixed line and this fixed line, those two have to be conjoined. They have to be because we know that they're going to meet at this point. The only thing we don't know is where it's going to collide down here. So as soon as you write 40.7 down here, that automatically sucks that guy there, and now we have a dangling arm kind of going like this. Do you see what I mean?
Okay.
All right. So the easiest way to do these is not to overthink it and just be like, okay, draw this diagram. Do B, side B is over here, so that means this is that other side that they gave me. It relieves you of thinking about where I'm going to put my dangling arm kind of thing. Does that make sense?
Yeah.
Okay. What's supposed to be your first check before you even find your height? There's a first check we are supposed to do. I said it every single time we did these. Yeah? The lowercase b? What about it? And remember, it doesn't matter what letter we have. We're just asking, is this dangling arm bigger than the fixed arm? So in this example, is B bigger than this right here? I'm asking that right now. Is this dangling arm longer than this side here? How many triangles are there? There's one triangle. This is category 4. If this dangling arm is longer than 40.7, then it's one triangle. So in fact, you should have been able to go straight to the answer and say it's one triangle. And that's because our B is bigger than our A. In other words, our dangly arm is bigger than our fixed arm. Okay, if you got this one wrong or it took you a long time, that just tells you need to add that to your notes, right? You need to put that in the notes. That's something that you miss. Because on a test, you want to be the person that finds the height and comes up with thinking there's two triangles. And then if I put solve on here, because if I ever did solve, it's probably going to be one triangle. And then you solve it and there's two triangles. And you're like, how did Mr. Pavin make me do all this in this one little box? Or do you want to be the person that's just like, hey, I read in my notes that I should do this check first? So make sure that's in your notes, especially if you didn't get that correct. All right, the first thing I want to do is I want to talk about the homework. Particularly which ones I actually care about. And more particular, which ones I didn't actually mean to put on there. So where are we? We are C, A. All right, first of all, did we have 30 or was it just 30? We had 30, we had 29 also, right? I don't have 29 on mine. But I'm not too concerned about 29 or 31. Those were tough bearing questions that I didn't even want to put on there. Those are the ones I didn't want on there. Because I wanted the ones that just had strictly that they go around. So if you got those and did it in the book, awesome. Those were like challenge questions. I care about 33. 33 is something that could appear on a test because it's almost identical to the one we did in class, right? We have 2 stakes and it goes up to a cellular tower. 35, let's talk about 35 really quick. I wouldn't put this on a test, but it's an interesting way. I wanted you just to look at it and think about it because it's an interesting way to describe a problem. So we're designing an addition and we have a 40-foot wide house that has a roof with a 6 by 12 pitch. That means the roof rises 6 feet over a run of 12 feet. And why this is interesting is because the roof's length, if we look at the roof's length, if we do everything to scale, the roof's length actually 20 feet. Okay, that has nothing to do with 6 and 12. That's why I picked this problem, because the numbers don't seem to match up, right? They're saying, all right, 6 feet for a 12-foot run, but I have a 20-foot run, so I actually don't know this size. So in order to do this, you would have to kind of form this triangle and find your angles. Okay, so this triangle here is a 6 by 12 foot pitch. So if we look at this triangle right here, we're going to use a different triangle to actually figure that out. So that roof pitch matches up with, or is a similar triangle to a smaller one that actually goes 6 feet, that rises 6 feet and has a run of 12 feet. So this is a right triangle. So the whole point of this triangle is just to figure out this angle. Because once I have this angle, I have that angle as well. And then we can use whatever we want to. We can use, and in fact, we can use this information to put these 2 angles down, and then we could actually get all of our other angles. So in order to figure this out, those that looked at the answer key or whatever would have noticed that, hey, it's a right triangle. So that would mean the tangent of, let's just go ahead and call this there. So the tangent of this angle is going to equal opposite over adjacent, which would mean we go on our calculator and actually be our angle equals the tan inverse of 6 over 12. Now I'm just setting this up just so you kind of see how to do it. So that would actually give me my angle of this degree. It would give me the angle of this. And once I have my angle, I can use that to get this side, right? I can use tangent again to say, hey, the tangent of this degree is going to equal my opposite over that. That'll give my hypotenuse. And the same information is going to work on this triangle that has a 3 foot by 12 foot pitch as well. All right? I'm not asking you guys to go back and making sure that you get all of this 100. I wouldn't put this on a test. This is a very, very complicated question. All right? I just want you to recognize that sometimes problems don't match up and you kind of have to think about, hey, this is a 6 by 12 pitch, and if you looked at the answer key, they didn't even talk about 6 or 12. Like, none of their pictures had 6 or 12 on it. That's particularly why. It's because they're talking about a different triangle that just happens to be similar, so you use that triangle to get the angle. So in fact, they're just telling you what's the angle of the roof. This 6 by 12 is just giving you the angle of the roof. The roof could have been 100 feet long, and it's still the same angle. Okay? And that's how a lot of times contractors talk, because the contractor might not know exactly how long a roof is going to be, but they know they want a particular angle. So when they think about, I'm going to go 6 up 12, 6 up 12, then they can do ordering and supplies that way until they figure out the full total length. All right, so this is common. This is common that a traditional slope can be a 6 by 12 pitch, where they talk about pitch and stuff. Okay, so that was the whole point of this question, just to get you thinking about it. Wasn't to ruin your life last night. The other one that is potential is the kite. The kite problem. That shouldn't have been overly super hard. So based upon the ones I picked out, did we have any questions? Were those the easier of the ones, I hope? All right, if you didn't do those, make sure you get them done, okay? Because I'm telling you that those are the type that could appear. And this one could appear, and I'm not saying for sure I'd pick this one, but I did it in the notes. I put it in the homework, and I pointed out that it's something that could be on the test. So if I was a betting man, it'd probably be this one over the kite, but that doesn't mean the night before I'm like, I really like that kite problem. Let's put that on, all right? But I would make sure I know how to do these. All right, any questions on the homework at all? Okay, good. I just want to clarify that sometimes homework's just challenge questions. All right, so far when we talked about the law of sines, we generally needed two angles and a side. Either it was angle, angle, side, or it was angle, side, angle, and we talked about the side, side, angle, but we don't mess with that much. So the primary ones you're thinking about for law of sine is two angles and a side. The law of cosines, however, deals with if I have side, angle, side, or side, side, side. So remember how we were doing our triangle checks? We were saying, does this match? Is this angle, angle, side? Is this side, angle, side? The reason for that is because now we're going to have the law of cosines. Where if I'm given a triangle that's side, angle, side, I'm going to use the law of cosines. If I get one that's side, 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 I'm going to use the law of cosines. So it's important for you to know what information is given to you to decide which law to actually use. Well, the nice thing is, well, not nice, because these aren't super nice equations, but they follow a very specific pattern. All right, they're all side plus side minus 2 times side, side, cosine of an angle. And why that's useful is because if I'm looking at side A, we're just adding the other two sides squared. The other two sides are being multiplied by 2, and then we use the angle of the side. So the only time we're actually using A is the angle. So if you can memorize this pattern, you basically have all of these memorized, all right? Because if I'm looking at B, I know I'm primarily using A and C. So I'm going to do A squared plus, I'm talking about B, so I'm going to do C squared minus 2, and this goes in the same order, AC. And then I know it's the cosine of B, because that's the side I'm looking for. So these are pretty, once you remember that pattern, it's not so much memorizing, it's just memorizing, it's the off sides that you're primarily doing. And these guys, it's kind of the same thing, that they follow this pattern that it's the off sides. So if I'm looking for cosine of A, we're going to use side B plus side C squared minus A squared all over 2BC. So there's a nice pattern there. It's just you kind of have to remember the look of it. All right. So these are a lot harder to memorize than the law of sines, because law of sines was nice. It was just sine A over A equals sine B over B. These are a little more difficult to memorize. What's happening out there? Anything good?
Nope, just observing.
Okay. So potentially, I'm not sure what I'm going to do on those, whether I'm going to give you a note card or something that you can write them down on. But just for right now, think about that you have to have it memorized. Okay? Just for right now, think about you have it memorized. Because if you have it memorized and they let you use a note card, hey, you don't even need it. It'll save you some time. All right? So just assume that we need to memorize those. All right, so these go real quick, and they're pretty easy. Like I said, all we care about is what type of triangle or what information is given to me. So if I look at this one, well, the information I'm given is a side, a side, and there's an angle in between. So that's going to be side, angle, side. And all I'm going to say is, does side, angle, side tell me to use law of cosines? Yeah, it's actually the first one. It said side, angle, side, right? I said, if you see side, angle, side, you can use the law of cosines. And we're going to use the side, angle, side law of cosines. So I kind of kept this in order. If you see side, angle, side, do this. If you see side, 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 do this. It's just going to be, if you have side, 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 and you do this, it will still work. You just have to manipulate it, all right? You'd have to subtract your B over C from here. You have to divide stuff. So sometimes it's just easier to memorize this. Okay, so we have side, angle, side. So that means we're going to use the side, angle, side rule. And let's go ahead and label some of this information so I know what I'm talking about. Let's call this A. Let's call this B. Let's call that C. So that tells me my B equals 3. My C equals 5. And I'm actually looking for my A. I'm actually looking for my A. So this says just set up an equation. Sometimes it's nice just to have one that's done that has the equation. So if I am looking for A, I'm going to actually write the whole thing out because it doesn't pay not to practice it. Remember, if I have A squared, we're going to use those off sides. So it's A squared equals B squared plus our C squared. And then it's minus 2 times those same two sides, so it'd be BC times the cosine of A. Now we just fill in our information. A is actually x in this problem. You could leave it as A, I mean it's just a variable. Let's just change it to x because that's what they have in the problem. My B is actually 3, so we'll have 3 squared. Plus my C is 5, so we have 5 squared. Minus 2 times 3 times 5 times the cosine of A, which is 39 degrees. And we don't have to solve this one. I just said write an equation. You can solve it if you want to. I just want to make sure we have the equation down. Because if you have the equation down, there's no reason for you to get this wrong on a test. And in fact, if you get it wrong from here, the most you lose is a half a point, because I'm assuming you just made a calculator error. Because this is all correct. On the next one, though, we actually are going to actually solve it. All right, so we have triangle ABC where C equals 60 degrees. So let's go ahead and write C equals 60 degrees here. We got A equals 10 feet. So that's that side that's across from A is 10 feet. B equals 14 feet. So this guy's 14 feet. Find the length of C. So I'm looking for this C out here. Can someone tell me whether I can use the law of sines or not? And why? Right?
Cannot. No, yes you can. You can do side, angle, side.
Good side, angle, side. Perfect. It's side, angle, side. So we can use the law of sines. Or law of cosines, I should say. Maybe I'll put that in there. Maybe I'll put, so that tells you to use the law of cosines. Well, we're looking for length C. So we're going to have C squared equals, it's going to be those two other sides. It's just those two other sides squared. So we're going to have 10 squared plus 14 squared minus 2 times those two sides. So that'll be 2 times 10 times 14. Do you think it matters what order I put these in? Nope, not at all. So what I honestly do is I know the side that I'm looking for, and then I just know those other two sides, and I go square one of them, square the other one, minus 2 times that side times that side. And that's going to be times the cosine. Well, if I'm looking for side A, that means it's going to be the cosine of, I'm looking for C, so it's going to be C's angle, which is 60 degrees. And go ahead and plug that in your calculator. Make sure you're getting good practice on it. You should come up with something like C squared equals 156, I believe. Tell me if I'm wrong. Sometimes I do these quick. Did it not come out to that?
Yeah, 156.
156. So if you didn't get 156, just double check. Do I care what c squared equals? I want to know what c equals, so I'm just going to take the square root of both sides. So we're going to end up with c. I put about 12.5 feet or somewhere about there. Just be careful when you're plugging these in your calculator. All right, you can actually plug if you have a graphic calculator, which you should all have, because that'll make it easier for this, especially if you're borrowing mine. I don't know who used mine on that one day that we came back. Those are pretty terrible to use for this one. But yeah, you can plug that all in. And what I do on a test is I usually plug it in twice. Right? I clear it out, plug it in again just to make sure I'm working with the right number. All right, but C is about 12.5 feet. Any questions on that one? No? Okay. The next one's kind of an application problem. It says, given that the wing of an F-106 Delta Dart is a triangle with two side lengths of 37.6 feet and 19.2 feet, and the included angle measure is 68 degrees, find the missing side length. Now, I believe I included a drawing on yours, right? I just want to make sure I match up the lengths. Can I see your picture real quick? Yeah, okay. So you should have a picture. I'm going to draw that triangle. Because a problem like this would need an included drawing because you're just not sure which sides and stuff we're dealing with. So we did this is going to be my 37.6. This was my 19.2. And that means the included angle means it's the one in between the two sides. So my included angle is 68 degrees. So this can be 68 degrees right here. Someone besides Mike, can I use the law of cosines on this one and why? Jack?
Yes, because it's side angle side.
It's side angle side, so we can use the law of cosines. So we're going to use the cosines. Law of cosines, side angle side. I'm going to label it. If you didn't, that's okay. I know most of you are trying to plug this in, and it's good. Try to get ahead of me. But my missing side of mine is A. So I would have A squared equals my missing side, or the sides I know. So that would be 37.6 squared plus 19.2 squared minus 2 times those two sides, so it's 37.6 times 19.2 times the cosine of whatever side I'm looking for. I'm using that angle, so angle A. Well, angle A is actually 68 degrees. All right, if you plug this in your calculator correctly, you should come out with about what'd you guys get?
1,241.5.
Okay, yep, that's what I got. 1,241.5. I would take the square root of both sides, and we come up with A is about 35.2. And we started with feet, so we're going to end with feet. The toughest problem we have for finding the law of cosines is if I give you just 3 sides. If I just give you side, 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 it's the toughest one to actually solve. And that's because we actually have to find a whole bunch of information. Well, not much. We have to find 2 angles. So we are given a triangular field that is 452 feet on one side, 572 feet on another side, and 574 feet on the third side. It doesn't matter how you draw it. I'm just going to draw it exactly the same as my notes so that everything stays the same and I'm not messing anything up. So I called the one on the left-hand side, I called that 452. I called the one on right 572. And the bottom one I put is 574. And I labeled it as A. And I went around the other way. I went A, B, C, so I put B up on top. The reason why it matters what you label it is because what letters I assign to it are going to look different if you don't have it the same setup as me. Well, this one's side, 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 so we haven't done that one yet. This is side, side, side. So that means we need to go back, because we haven't used that one yet, and look at what happens if it's side, side, side. Well, if it's side, 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 whatever angle I'm looking for, we're going to take the two other sides, square them, subtract that same side, all over 2 times the two sides I didn't use. So I went ahead and I believe I solved A first. So I put a little wall because we're going to have to do a little bit of work. So I did A first. So I said the cosine of A, well, that's going to equal the two sides that have nothing to do with A. So if you remember, A is the one that equals 572. So I'm going to do 574 squared. We add the other side that's not A, which is 452. Square it. And then we subtract A squared, which is going to be 572 squared. And that's all going to be over 2 times the two sides that aren't A. So that's going to be 452. And maybe I should put in the same order as on top. So let's do 574 times 452. If you're really worried about parentheses and making sure everything's correct, what I would do is I would do the whole top, hit enter on my calculator, and then divide and make sure I put this in parentheses, this bottom one in parentheses. Okay? Because you want all of this in parentheses. So if I'm using a calculator, I'm going to put this all in parentheses, because if you don't put it in parentheses, what your calculator is going to do is just take this divided by 2. And then it'll do the multiplication afterwards. Okay, so make sure you put this bottom in parentheses. So if using calculator, make sure you put these in parentheses. And make sure you're doing it correct. So I'm going to put up the answer, and I want to make sure you can do it. You should come up with cosine A equals 0. I rounded it to 40. Did other people get that? Did that match? Can I put 0.40 right here in A? Oh, no. No, I can't. I need to get A. How do I get rid of the cosine and just get A by itself? The cosine inverse. So I'm going to take the cosine inverse of both sides, which is going to get rid of my cosine. I'm going to take the cosine inverse of this side. Luckily, you have a cosine inverse button on your calculator. And can someone tell me what A is going to equal about? What'd you get? Okay, thanks. 66.5 degrees. All right, if you would, I want you to find B. I want you to find B, okay, and round it to the 100th place. I'm going to be solving B up here as well, so if you get stuck, you can look up. But I'm going to start solving up here. I'm just not going to talk through it. I want you to look down and do it as much as you can on your own. is area of triangle. So the area of an oblique triangle using the law of cosines. Hey guys, let's make sure we pay attention to this stuff real quick, and then you guys can talk. The area of oblique triangle using when we break it all down. So the area of an oblique triangle is going to be 1/2 side A times side B times sine C. So you basically take two sides, and then you're going to take that, you're going to take the trig function or the angle of that third. All right, so if it's A, B, C. It's B, C, A. It's A, C, B. Now I put two formulas down. I put two formulas down because you are going to use that top one if you have side, angle, side. So this guy is if you have side, angle, side. And this bottom one is if you know side, side, side. All right, so there are problems in the homework. Where is it? That we're supposed to use the most appropriate form to solve the triangle. So this one is side, side, side. That's going to tell you, hey, go back to that page. Well, all I need to do is figure out the area using this. So this is going to be a big, long equation. Okay, that's why you have a little bit of space there. Because this is s times s minus a, s minus b, s minus c. The first thing you're going to do is solve for s. All right, you're going to throw your three sides in there, divide by 2. Whatever number you get out there, plug it in for all your s's, and just plug in your calculator. Okay? So solve for s, and then plug it in. If they give you side, angle, side, you go ahead and plug it in there. If you can just solve it, remember that the area of a triangle is half the base times the height. So if they give you a base and a height, then you can go ahead and solve it that way as well. All right, these are just two additional ways to do it. All right, go ahead and get started on the homework.